Hello viewers, welcome to Math with Kantoma. In today's lesson, we'll be discussing about trigonometry. Trigonometry. What is trigonometry? Trigonometry is derived from a Greek word or a Latin word. A three Latin word, which is tri, gono, and metry. Tri means three, gono means angle, and metry means measurement. So therefore, literally, trigonometry means three angles measurement. So now what are these three angles we'll be discussing in trigonometry? The three angles are derived from this word, SOHCAHTOA. So now we'll be discussing these three angles. The three angles are, the first S here stands for sine. This first C here sine stands for cosine, and then the T there is standing for tangent. So now, these are the three basic angles we'll be discussing in trigonometry. And then the use of this SOHCAHTOA will now give us an insight of what truly defines these three angles. If we plot a triangle, a right angle triangle, like this is a right angle triangle, and by definition we say the longest line is usually the hypotenuse. Then if we have the angle of inclination here, opposite to this angle is called opposite. Let's say this is A, then this line is called the adjacent. Let's say this is B, and then the longest line we say is the hypotenuse. Let's name it C. Assumption. By assumption, we assume this line to be A, this is B, and this is C. So now, using Pythagoras' theorem, the theorem says hypotenuse squared is equal to opposite squared plus adjacent squared by Pythagoras' theorem, right? So now, deducing these values using the angle of inclination here as theta, we said theta, sine of this angle theta, which is what we refer to as sine theta, is given by definition. Using SOHCAHTOA, by definition of sine, we say sine is opposite over hypotenuse. This is the first SOH. So, meaning sine is opposite over hypotenuse. So, sine is opposite over hypotenuse. And also, cos of this angle, cos theta, cosine of this angle, meaning cos theta, is by definition is defined as cos is adjacent over hypotenuse. So this is adjacent all over hypotenuse. And the last, which is the tangent. So now tangent of this angle, or tan of this angle, is defined as toa, meaning opposite over adjacent. This is opposite over adjacent. So this is the sine, the tan of the angle. So by definition, using SOHCAHTOA, we define what a sine theta is, which is opposite over hypotenuse, and then cos theta is adjacent over hypotenuse, then tan theta is defined as opposite over adjacent. So now these are the three angles. So now, if we go back to our Pythagoras theorem, which says hypotenuse squared, this is my hypotenuse, the longest line. Hypotenuse squared, meaning C squared, is equal to opposite square plus adjacent square. Opposite of this angle is A, meaning A square, plus the adjacent to the angle is B, A square plus B squared. Now, we are aiming at deriving the first identity on trigonometry. We want to derive the formula for the first identity equation in trigonometry. And in doing that, let us divide through by the hypotenuse on this formula. Dividing through by the hypotenuse squared, which is C squared. Divide this all through by C squared. This will go with this, so we'll be left with A squared over C squared plus b square over c square is equal to 1, right? Is equal to 1. So now, this value can be written as a over c all square plus b over c all squared is equal to 1, right? So now, by definition of sine of this angle theta, we're using this triangle now. Sine of this angle, we said, is defined as opposite over hypotenuse. And what is opposite on this angle is A. Opposite is A, hypotenuse is C. So we have A over C as sine theta. Likewise, cos theta, by definition, we said is adjacent over hypotenuse. Cos theta, this is my adjacent, this is my hypotenuse, which is B over C. And the same thing goes for tan theta. Tan of this angle, we said is 2 are opposite over adjacent. Opposite is A, and adjacent is B. A over B. So now, substituting these values with sine and cosine on this formula, we have A over C. A over C we said is sine, and this is squared. So this is going to be sine square theta plus B over C. B over C is cos, and this is square, so we have cos square theta is equal to 1. So now this formula is our first identity equation, and we call it equation 1. The first identity equation 1. So now from this first identity equation 1, we can deduce other identity equations. So now from this equation 1, from 1, I can deduce other equations. Equation 1 says sine square theta plus cos square theta is equal to 1, right? So now, what if I divide through by sine square theta uniform? Or before dividing through by sine square theta, let us define the inverse equation, the inverse identities. So now the first inverse identity we have is tan theta, and tan theta is defined as sine theta all over cos theta by definition. Tan theta is opposite, by definition we said is opposite over adjacent, and sine theta here can be written as, if we take opposite is A, adjacent is B, I can still prove that A over B is the same thing as sine theta over cos theta, meaning A over B. Is it the same thing? Because by definition we say tan theta is opposite over adjacent, and opposite is A, adjacent is B, right? So now what is sine theta? By definition sine theta is opposite over hypotenuse, is A over C. So I have A over C divided by cos theta. By definition we said is B over C. B over C. So therefore this A over B must be the same thing with this value. So what is A over B? This can be written as A over C divided by B over C. So mathematically I can change this sign into multiplication by taking the reciprocal of this very fraction. So here I have A over B is the same thing as A over C times C over B. This C will cancel this C. So I will multiply this. I have A over B is equal to A times 1 is A, C times B times 1 is B. So therefore A over B is equal to B over A over B. So this is uniform, this is equal. So therefore tan theta, instead of writing A over B, I can still write it as sine theta over cos theta. That is by definition. So now this is the first inverse identity, and then the second inverse identity is cot theta is defined as 1 over tan theta, and is the same thing as cos theta over sine theta. If you take the inverse of this, if this is up and then this one is down, we said is inverse. This is cos theta over sine theta, and this is the same thing as 1 over tan theta and is equal to cot theta. Then the next is sec theta, and sec theta is defined as 1 over cos theta. This is also an inverse identity. 1 over cos theta is sec theta. Then also cosec theta Cosec theta is defined as 1 over sine theta. The inverse of this. All of them, if you take the inverse of all these sine, cosine, tangent, the three angles we are talking about in trigonometry, if you take the inverse, it will give us the inverse identities formulas. So these are the three inverse identity formulas, or four inverse identity formulas, which is tan theta, sin theta over cos theta, cot theta is 1 over tan theta, sec theta is 1 over cos theta, and cosec theta is 1 over sin theta. So these are the three identities. Now, going back to our first identity equation 1. In first identity equation 1, we say sin square theta plus cos square theta is equal to 1. So now, if I divide through by sin square theta, let me see what I'm going to have. Divide through by sin square theta, divide this by also sin square theta. So this will go with this. Here I have 1 plus cos theta over sin theta. By definition, what is cos theta over sin theta? It's cot theta, right? So instead of writing cos theta over sin theta, I can write cot theta. But remember, all these are squared, so I'm going to have cot square theta plus 1 over sin theta. 1 over sin theta by definition is cosec theta, but the sign here is squared. So I'm going to have this is equal to cosec square theta. So let me call this equation 2. This is the second identity equation. So next from equation 1, I can still deduce equation 1 to give me another identity equation. From equation 1, which says sin square theta plus cos square theta is equal to 1. So initially I divided by sin square theta, so I'm going to divide now by cos square theta. So divide all through by cos square theta, divide this by cos square theta, and divide this by cos square theta. So now if we divide through by cos square theta, we're having sin over cos. Sin theta over cos theta, we set is tan theta, right? So now instead of writing sin theta over cos theta, I'm going to have tan theta, but these are squared, so I'm going to have tan squared theta plus cos square theta over cos square theta is 1, so I have plus 1 is equal to 1 over cos square theta. 1 over cos theta is sec theta by definition. So instead of writing sec theta, I will have sec square theta because this is also squared. So let me call this equation 3. So now these are the three identity equations, but from them we can also deduce other equations. So I'm going to see how to manipulate or use the identity equation and solve various problems. But before we go into that, we'll be looking into some functions. So now on some functions, we'll have to define sum of. So now from the sum function, we said sin A plus B. We are given two angles now. These are two angles, A plus B. By definition, sin A plus B, we say it is equal to sin A cos B plus cos A sin B. Let's say this is equation 4. And also sin A minus B. If one of the angle is negative and the other angle is positive, then we are going to have sin A cos B minus cos A sin B. Let's say this is equation 5. Again, for cosine, we have cos A plus B is the same thing as cos A cos B minus sin A sin B. Let's say this is equation 6. And again, cos of one angle to be negative, cos A minus B is the same thing as cos A cos B plus sin A sin B. Let's say this is equation 7. So in our next class, I'll be proving to you how we arrive at these formulas. But for now, we're going to use these formulas to derive other tangent formulas. So now, these are the formulas we'll be using to derive other formulas that has to do with either the double angle, the triple angle, or the half angle, or whichever angles we want to derive at. So now, using these formulas, I can define what tan A plus B is. Meaning tan A plus B is the same thing as, we know tan by definition is sin theta over cos theta, but we are dealing with A plus B here. Our angle is A plus B. So it's going to be sin A plus B all over cos A plus B. And by definition, we know what sin A plus B is. Sin A plus B is given by this formula. So I can substitute this formula into, say, sin A cos B plus cos A sin B. Divide this by cos A plus B is also given by this formula. This. So I can substitute it as cos A cos B minus sin A sin B. So from here, what I'm looking for is tan of these two angles, A plus B. So what I will be deriving here, it has to be related to tangent of this angle. So now I'm going to divide sine over cosine to give me tan. So I must divide all through by cos A cos B, because I'm dealing with two functions, sine and cos. So I'm dividing everything here by cos A cos B. So if we divide all through here, then we say tan A plus B will now be giving us sin A cos B. Divide this by cos A cos B, cos A cos B, plus this one we have cos A sin B divided by cos A cos B. Then this divided by this value here, we have cos A cos B divided by cos A cos B, then minus sin A sin B divided by cos A cos B. So now I can cancel out this. This is common. Cos A cos B will cancel cos A cos B. And likewise here I have cos B will go with cos B. Here I have cos A will go with cos A. So these are uniform, right? So now what I'll be left with is tan A plus B now. Tan A plus B is equal to, I'm left with sin A over cos A here. Sin A over cos A plus, what is left here is sin B over cos B. So I'm left with sin B all over cos B. Then divide this by, what is left here is 1 minus, what is left here is sin A sin B cos A cos B. So I have sin A over cos A sin B all over cos B. So now instead of writing sine over cosine, I can simply write it as tan, because sine over cos is tan. So therefore I have tan A plus B is equal to sine A over cos A, we said is tan A, plus cos B over sine B is tan B. Divide this by 1 minus sine A over cos A is still tan A times sine B over cos B is tan B. So let's say this is equation 8. So now this is another identity equation. Oh, sorry, the function, the sum function, which is for tan, we have tan A plus tan B all over 1 minus tan A tan B for tan A plus B. So now next we'll be looking at, after these equations, is the double angle formulas. And on the double angle formula, double angle formulas. So now on double angle formulas, when we say the double angle, we mean when the two angles are equal. In the case here, I have angle A is different from angle B. So what if they are equal? If they are equal, meaning A is equal to B. and B is equal to A. So if A is equal to B, then that will lead us to what we call the double angle. So therefore, instead of writing sine A plus B, I'm going to write sine A plus A here, because both of them are equal. A is equal to B. So I have sine A plus sine A, which is equal to, from this formula, we know that sine A plus B is given by this, sine A cos B. So instead of writing sine A cos B, I can write sine A cos A plus, instead of cos A sine B, I will write cos A cos A, because A is equal to B. So I have cos A sine A. So now if you look at these two, both of them are equal. Sine A cos B cos A sine A. This is commutative, and we said addition and multiplication are commutative over the set of real number, meaning x times y is also equal to y times x. So if I can arrange this by writing sine first instead of cos, so this is the same thing as sine A cos A plus sine A cos A. So sine A cos A plus sine A cos A is 2 sine A cos A, right? So therefore, A plus A here, I have sine 2A is equal to 2 sine A cos A. So let me call this equation 9. And this is for sine. Sine, double angle on sine. So now let's define what a double angle is on cosine. So for double angle on cosine, we said cos A plus A, because both angles are equal. A is equal to B. So instead of writing cos A plus B, I can write cos A plus A. So now cos A plus B is given by this formula. So wherever you see B, we just substitute it by A. Simple. So we substitute. This is equal to cos A minus sine A, right? So now what is cos A times cos A? Cos A plus A here is equal to cos 2A, is equal to cos A times cos A is cos square A, minus sine A times sine A is sine square A, right? So now let me call this equation 10I. This is equation 10I, because I can deduce other equations from this equation. Meaning, remember from our first identity equation, remember from equation 1. From equation 1, and equation 1 says sine square theta plus cos square theta is equal to 1. But here we are not dealing with theta. We are dealing with angle A. So instead of writing sine square theta, I can write sine square A plus cos square A is equal to 1. This is from first identity equation 1. So I can substitute, make sine square A the subject. Therefore, sine square A is equal to 1 minus cos square A. Right? So now I can substitute the value of sine square A as 1 minus cos square A in this equation. Instead of writing sine square A, I can substitute it with this. So now this will lead me to have cos 2A is equal to, instead of writing, I can write this is cos square A minus, instead of writing sine square A, I can substitute it by this value. So minus, in bracket, 1 minus cos square A, right? So if I factorize, open this bracket, I will have cos 2A is equal to cos square A minus 1 minus is plus cos square A, right? So cos square A plus cos square A, I will have 2 cos square A minus 1. So therefore, cos 2A is equal to this. So I can take, this is equation 10I2. So next, from equation 10 again, I can substitute the value of cos theta from equation 1. Cos square A from equation 1. From 1 again, I can make cos square A the subject, meaning cos square A is equal to, let this one crosses the equality, 1 minus sine square A. So I can also substitute the value of cos square A in equation 10. Right? So now the value from equation 10, I have cos 2A is equal to, instead of writing cos square A, I can substitute it by 1 minus sine square A, then minus this value, sine square A, minus sine square A. So now I have cos 2A is now equal to 1 minus sine square A minus sine square A is minus 2 sine square A. We have minus 2 sine square A. So this is equation 10I3. So now the double angle formula for cos 2A is now reduced into 3 formulas. So we have the value for cos 2A as cos square A minus sine square A, and also the value for cos 2A is also given as 2 cos square A minus 1. Again, the value for cos 2A is also given as 1 minus 2 sine square A. So now we'll be using this 2I formula to deduce the half angle formula. This very formula will be used to deduce the formula for half angle, but we are not going into that for now. Let us continue and find the tan for double angle for tan theta. So now tan A plus A, now instead of A plus B we said A is equal to B. So what is tan A plus B? Tan A plus A, we said by the formula tan 2A or tan A plus B is given by this formula. So now substitute wherever you see B as A. So we are just substituting. We have tan A plus tan A all over 1 minus tan A. Wherever you see B, we just change it to A. So from here, tan A plus tan A is the same thing as 2 tan A. Divide this by 1 minus tan A times tan A is tan square A. So this is equation 11. So now this is the double angle formula for tan A. So this is the double angle formula for tan A. So now after the values for this double angle formula, we will be looking into the triple angle formula also. So the triple angle formula, let's define the triple angle formula quickly. Or we can stop here and then we define what the triple angle formula is in our next class. Thank you for your time, and don't forget to subscribe, like our page, and hit on the notification bell.